Hi, it's Mike. Welcome to the shop. Been a while since I've done one of these. Seems like I say that a lot lately, but it's really been a while on this one. Oh, and I've got a lot of stuff, just a lot of side jobs. A lot of things going on in life. So anyway, what we're going to work on in this, pardon me if this is a little disjointed. I filmed it over a period of about a month and a half, 2 months, just because I haven't had enough time to actually finish anything or get it edited. So we've got some work on a Tapmatic tapping head, and then a set of copper vise jaws. I think that's about all. I can't even remember everything that's filmed. So I'll edit it together later. Hopefully this will make sense. And as always, thanks again, and welcome to the shop. So this is a now disassembled Tapmatic 50X tapping attachment. So it covers number 6 through 1/2 inch, roughly 3 millimeters through 13 metric, and it'll work with either. It doesn't care. So this thing did not want to come apart. It had been beat to death. So the first indication is you're supposed to unscrew this off of here. First, you're supposed to take a snap ring off, which wasn't there. Unscrew this. And then it says, and the springs will just pop out. Well, here's the springs. Let me zoom in on the springs so you can just see how buggered those are. So as you can see, every single one of these is bent over at about 90 degrees. Well, it was 90 degrees. It's a spring, but they're destroyed. There's supposed to be 9 of them that go in here, and you tighten the sleeve, and it puts pressure on the clutch pack. So all those were destroyed. Somebody horribly abused this. So the next part, this is even better. So this in the bottom of here is where the tap goes in, along with this nut. Make sure that shows up on camera. All right, it does. All right, so this is where the tap goes in, and there's a nut. So this has got to be cleaned up. And normally there's a Jacob style rubber flex collet in there. Well, that's what's left of the rubber flex collet. It's just a few pieces of metal and a little bit of rubber. In comparison, let me show you what a new one looks like. So here's one of the new ones that Tapmatic sent. So that's what it should look like, where it will, go in there. And it adjusts down to hold the tap. Now the key is, and the reason that this is destroyed, is that the collet is not supposed to keep the tap from turning. That falls on this little guy. Let me zoom out a little bit, I think. See that better. So the way this is supposed to work is inside of here there's this, it's got a left and a right hand. And this is supposed to hold the square shank of a tap like this and keep it from turning. You can see it's chowdered up. It's just all buggered in there. So what would happen is, since that didn't hold the tap, the collet was trying to hold the tap, the collet is to keep it centered. I mean, it goes in there, tightens down, and it just keeps the tap centered, and the driving torque is on the square shank with that little block, which I also got from Tapmatic. That's what a new one looks like. That's what the buggered, chowdered up one looks like. So that has to go along with the junky springs. I ordered, they sent me the snap rings that I needed. And let's see what else I got. So I got two of the rubber flex collets, a small one, a large one. The snap rings and the springs, which really is all the parts I think I need. There's a thrust bearing, which seems to be fine. All it is for adjusting the clutch pack, so it's not a high-speed thing. This is the planetary gear. It appears, other than to be really dirty, to be in decent shape. I don't think there's a problem with that. I think it'll work. If not, then we'll have to get one. Then there's the ball bearing and the planetary assembly, and it doesn't have any slop. It turns nicely. The sun gear, or the outer planetary, I can't think of what it's called at the moment. You got the sun, I don't know, stars, and whatever. Doesn't matter. It's the outer ring of the planetary system, and then the inner planetary also goes in, and it all fits nice and rotates well. So I don't think there's any problem with the planetary gears other than they need cleaned. The ball bearings seem really good. This is the clutch pack. Its ball bearing seems good, although you can see the shield's been bashed, but there's no binding on it. It turns nicely, so I think we're fine. It doesn't have any slop. You can see on here where it's actually spun because they didn't, somebody abused it terribly. There are 3, hopefully this all shows up. I think it will. Let me go look. Yeah. All right. So there are 3 pins in here that drive this clutch pack. They should all be the same distance. These 2 are flush with the top. This one's down further. So I'm going to, we'll reseat that and get them all the same. So we'll take the clutches out of here. Sure. Fiber discs are just standard, you know, like a motorcycle clutch or something like that. They're just little fiber discs. So we are going to put those in lacquer thinner, like the folks at Tapmatic suggested. And the other thing we'll do, which is actually going to involve a little bit of machine work, so that'll be good, is on here, you can see this is where, let's get our new snap ring here. So this is where our snap ring to hold that adjustment cap goes, and you can see it's been, somebody whacked it with a hammer or something, and it's all folded over. So while I could file that out, I think what I'm going to do is just chuck it up in the 4-jaw, because we got something here, and in the end of our Morse taper, we've got a center drill, so we'll hold this really nice and just clean that up. There's one here, but there's nothing that goes in there really, so I'm not going to worry about that one. But we'll just take a small, triangular, narrow triangular 35-degree insert and just kind of dig that out very carefully, just so that we can get our snap ring in there. It's not very critical. We just need a groove all the way around. I could file it, but like I said, we've got a lathe, so we'll do that. And we'll get her cleaned up and put back together and maybe drill a hole and see if we can tap some threads. Depends how far I get tonight. So I think the first thing we'll do is just throw these plates in a little lacquer thinner and let them get soaked up while we're working on the other stuff. Got to get something to pry on this one. Oh, here, this will work. All right, we'll get that out. We'll wipe this one down. We're not going to soak that because of the bearing. So these are just fiber plates. I don't think there's anything wrong with the clutch other than it's greasy, which is not what it's supposed to be. So we've got our discs. There's nothing, as far as I can tell, they're all right. They're not really chewed up. They're just kind of greasy more than anything else. So, and it doesn't smell very good, so it's been hot at some point. So throw a little lacquer thinner in there, which is seemingly getting harder to buy. The Home Depot did not. I couldn't find any there. I had to go to a real hardware store. Thankfully, I live near a small town, and we still have a real hardware store. So, yay, true value. So, whew, that stinks. We'll be in the other room, thankfully. Let that go for a little while, and then we'll, oops, stuck together. No, it's one. So we'll let those soak, and then blow them off with a compressor. And he said, the Tapmatic guy said, let them dry really good. So we may not assemble the clutch tonight. Go put that in there too. And there goes my phone. I got to move the camera anyway. I thought I'd also show this really quick. I don't know, a while back on Tom Lipton's Ox Tool Co. channel, he showed he got a new real quiet air compressor. I have a 60-gallon in my mechanical room, which is great when I need to run the press or something, but it takes a lot of electricity and it makes a lot of racket when you're using it just for using a blowgun. And I have a little three-gallon pancake compressor, which makes even more racket. So I had a little extra money from some of the customer work, so I invested in a new one of these, like a similar, I don't know if it's the same one that Tom showed, but it's 2 horsepower, 10-gallon California Air Tools. Got it off Amazon, came in 2 days, free shipping, all that good stuff. You can actually carry on a conversation while this is running. It's not silent, but it's pretty darn quiet. It's full up right now, right? Turn it on, but it may come on while we're working. But anyway, it's a pretty cool little unit. So far, really like it. No issues so far. It has 2 connections, so you could run a blowgun and a little, sander or something like that, a nailer, whatever. Pretty good. It's got a release valve so that the motors can start the compressors, or I guess they're compressors, the pumps, without a load on them. So if it's got 100 pounds of air in it, it doesn't have a big starting current, which is true of a lot of them. So that's actually kind of cool. It wastes a little air when it starts and stops, but it works pretty good so far. But anyway, we'll get to the actual job now. So, all right. So I've already put the four jaw on the lathe. So here's our piece, and let's get this opened up, and let me move out of the way. Move the camera a little bit so we can get it dialed in. Okay, just open up our chuck a little bit here. Still got copper jaws in it from a while back when I was working on a piece of copper for a guy, and certainly didn't want to mar it up with the chuck jaws. So I'm not going to bother to take them out because this is aluminum anyway, and we don't want to chowder it up. We got to go quite a bit more. Just eyeball it to get it close. That's probably pretty close. Yeah, that's not terrible. Put an indicator on there. See where we're at. So there's not a lot of great surfaces on here, but we can get right down in here. This is actually probably pretty good. I mean, if we get it within a few thousandths, it's probably plenty good for what we need. So we'll get our Noga here. Whoops, turn that around. Here we go. The only problem is that's tapered, and so we can't go back and forth. It wouldn't be accurate, but if we can get it pretty close, it'd be good enough. Okay, so that's quite a ways out that way, and we're about, so this is 5/10 indicator, so we're about 50 something that way. And so we'll back this off just a little. Go about 25. See where we're at. So a little more on this one. Okay, we're pretty good there. So on this one, we're going to go in a little. Oh yeah, we're pretty good. At about, we'll zero the dial. I don't know if you can see the dial or not. But, close enough. So we got a little over zero there. About zero there. So we can go in just a hair on this one. Probably too much. I don't want to go super tight on this because it's hollow and we don't want to break it or deform it. There, that's probably pretty good. Yeah, within the thou, maybe a little less. So we're going to call that good because all we're doing is truing up that ring groove. Not truing it up, cleaning it up. Okay. We've got our center in pretty well trued up. I could recheck it, but I'm just not going to worry about it. I think we're all right. Okay, so what we're going to use is this 35-degree insert tool. This one's for cutting aluminum. It's a DCGX. So we're going to come in here, you know, to kick it over about like this, and then just kind of, you know, so that the tool is square, and then just kind of wiggle it back and forth till we get that burr out of there, just enough to the, so the snap ring will go in. Get the lathe fired up here. This should only take a minute. It's been out here in the cold all day. It's probably going to be whiny. Oh, we lost our center when I put the hand in. We are way out of round. All right, let me get the indicator and true it back up, because that is not going to do. Must have moved when I tightened up the tailstock. I should have checked it. Didn't worry about it. I should have. Okay, we're within about half a thou. Let's see how it looks when it turns. Oh yeah, that's better. So we got about a thou. I'm going to call it good for this. I'm just not going to worry about it that much, but 5 or 10 was not going to work. All right, so let's put our tool in. Index our post over a little bit. And that'll do right there. Definitely like having the index in the bottom of the tool post. It makes things like this just a lot easier. So we'll just run it slow. And kind of lined up there. Probably hear it. So there's our buggered part. We're really not touching too much other places, so take a little bit more very carefully. We're pretty well centered. Okay. I think that'll do. We don't want to take much off. That looks pretty good. Let me go get the snap ring, make sure it fits. So here's our ring. Of course it fits where it's supposed to, but seems to be all right, even in that little spot. Let me get my magnifier so I can see what I'm looking at here. Yeah, we're going to call that good. So there's not much lathe work on that. I'm not sure exactly what we'll do on the spindle, but I'm going to go get that and we'll put it in here and see what happens. So let me see if that shows up on camera there. So you can see here was our little buggered part. So we have a groove now that goes all the way around. It's still buggered on the outside, but the groove is good, and that's all that matters. And that's just to keep from accidentally unscrewing the tension setting ring. So this is the spindle where the tap goes in and the flex collet. And you can see the inside of it here. It's got some, I think it'll show up. Yeah, it's got some pretty nasty gouges in it. I don't really want to make it much bigger. I really don't want to make it any bigger, but it's kind of nasty, and as long as we maintain the taper, I think we're good. I'll have to try to figure out what the taper is. We can make it with the match it with the indicator. So for this part, it's let's chuck it up. This we will get really true because we want it to run true. Even though it kind of floats, we definitely want it true. Not sure what we can reach in there with. Maybe a small boring bar might be a good thing. So maybe we can reach in here with a, yeah, see this is small enough to go inside. So we'll probably reach in here with a small boring bar, carbide, and see if we can cut this. It's pretty hard, but oh yeah, this will cut it. There won't be a problem there. So we'll true this up and figure out the angle, lightly skim it. I mean, it really kind of looks like 90 degrees. I'll measure one of the flex chucks. I could go look it up. Let's see what we got here. A little on this one. And it should be pretty darn good. Look at there, it don't move at all. We're dead nuts. So maybe a 1/10, maybe 2, way less than 5. So we're gonna call that good. And see what we can do for put the boring bar in. Well, we got to get the angle. So let me grab one of those rubber flex jobbies. Okay, so here's our here's one of our collets that goes in there, and looks like our angle, I was wrong, it's not even close to 90 degrees. It looks like if we'll go this way, it's a little easier. So if we put this up against the steel and this up against the chuck or the insert, looks like we got right at a 70-degree angle. So it looks really close to 70 degrees. I can't imagine they'd use some really obscure thing. So we'll set the compound so that we're cutting 20 degrees off of center, and you know, it's 90 minus 70, and then we'll put an indicator on it and see where we're at. That's pretty good. That might do. So let's just back this out. You can see the dial there, and we'll run this in and out. And actually, for just a rough eyeball, we're off about 5 thousandths over the distance of the taper, so that's not too bad. Compound and check it again. Hopefully it won't move on us. I had it pretty snug when I was tapping on it, so we should be all right. Yeah, other than the surface roughness, we're good to go. All right, so now we'll get our boring bar on there and just see if we can skim it without screwing this up. So I just want to get some of that roughness out. Okay, for this we're going to use it's a borite, made in USA brand, which is nice. They're actually really nice boring bars. I got a set of 8 of these. They use these funky little TT 221 inserts, which are not very common, but they are viable, and you know, they get 3 per bar. Anyway, they're all 3/4 shank because that fits my bigger boring head for the mill. But they also work well in the tool holders. So, and this may be of interest. So this is a Dorian BXA sized holder. Typically, the holders that you use on a BXA size machine are 5/8. There's a company called All Industrial Tool that sells an oversized XL. They label them Hess, and they're Chinese, but they're a lot better than a lot of them. Even the screws are pretty good in them, because some of the Chinese ones are just awful, bad screws. So I picked up a couple that had some V grooves in them when they were available last, so that we can put this in there and we'll get it centered up and get a reasonably good cutting angle here. Give it just a couple degrees of rake. I don't really know how this is going to cut, but we'll snug it up these down out of the way a little bit. Here's our handy dandy little height setting gauge. And right now, it's way high. It's not terrible. That'll put that on center. Let me see if I can move the camera and actually get a view of this. I'm not sure. Let me see. Okay, there's our. We're gonna try to cut our little taper in there. Just not really. We don't want to make it bigger. Just clean up the buggered parts. Okay, this is our part. It's turning at about 200 RPM right now. You can see even the edge of this where it's kind of ugly looking, but it is running nice and true. So I might take a very light facing pass on there, or maybe I'll just hit it with a file, because I don't want to really take metal off to speak of, but I've got to clean it up. It's pretty bad. So I've locked the carriage. Just going to back this out. It almost looks like the end of it's bent. So we'll just bring this out until it just touches. I heard somebody come in my door. Anyway, you can hear this thing just touching on one side, so we're just going to take just a couple thou off. I just want to clean it up. See what it looks like here. Now looks pretty good on this side, but over here it still isn't touching, but it's close. We're not too far off. A few thousandths more I think will be pretty good. But I don't really want to take a lot off, but it was pretty bad. I'm going to take 2,000 steps to cut this time, and maybe that'll clean it up. A little oil on it. There we go. This is actually a brand new boring bar. I haven't used this little one yet. So it's a nice new insert, so it cuts real well. Okay, and that's the end of it. I'll take it out and show it, but it looks a whole lot better inside. Our flex collet feels really good in there. So this has now got a pretty sharp edge on it because it was already crappy. So actually I think I'm just going to take a file with that. Not going to try to face it off any. Get a file and we'll clean that up a little bit. And we'll put a nut on it and see how it works. File ain't working too good on it. It's not quite file hard, but it's pretty hard. See how it feels. Yeah, the thread's kind of boogered right here. It's not too bad. Maybe I don't know. It's It is filing, just not very fast. I just really don't want to use a lathe tool on it. Yeah, it's cutting, but it isn't. I don't know if you can tell, it looks kind of like an Acme thread, which it may well be. That's pretty good. We'll get the nut and see how it feels on there. See how we feel if it threads on good. Oh yeah. Say that's fine. So that's took the sharp edge off. So we'll put our collet in there. And, it's got to be compressed just to get it into the nut. So let me do that. All right, so now I've got our collet in there. Should just thread on nicely. Oh yeah, that feels really good. So this tap came with the tapping chuck head, so it may not be straight either. Actually, that's a lot better now that it's got a lot more to bite on. It looks like it's actually running, and it's not perfect. I can see the center moving, but I think we'll be all right. The tapping head floats. Yeah, this is dead true. It is definitely not true out here. So I think we'll be all right. It's certainly an improvement. I can buy it if I have to from Tapmatic, but given that that's a machined part, I expected it to be fairly expensive. So I think we're going to be all right with that. I think so. The next step will be to we'll drive our pins in till they're all flush on this side. It's just basically one, and get everything cleaned up and reassembled with some lube. And I'll probably clean most of it up off camera because that's just not very exciting to watch. Well, the tapping head project is going to be on hold for a little while. I was cleaning up all the parts, and this is the ring gear. Goes around here, which is fine, except for while cleaning it up. I don't know if this shows up or not. Hopefully you can probably see. It's broken. It's got a big crack through it. Well, the housing will tend to hold this closed, but still not acceptable, so I got to order a new one. Do that this week, and hopefully we'll get back to this soon. So instead of that, just because it needs done, and I finally ordered the material, I'm going to make a set of a little piece of copper. We're going to make a set of jaws for my little cheap bench vise.